All right, so we're back for lab 2, I guess. So today we're going to import data and just the different ways that we can import data into our studio. Okay, and so first things first, I'm going to start a blank RMD file that we learned about in lab 1. And so because this is a new computer that I'm working on, it's going to ask me if I want to install these packages right now, and yes, I do. And so should be pretty quick. While it's doing this, oh, there we go. And so I'll just say lab 2, and I'm the author, and okay. So now we get this default document, and just to clean stuff up, I'm gonna delete everything. I'll start fresh, feeling wild. So I'm gonna say make a label, so importing data. I'll make a blank R code chunk by tick, tick, tick. So underneath the escape key, tick, 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 and then curly brackets. Inside those curly brackets, I put a lowercase r, and then I close it up, tick, tick, tick. And now see this gray area should just be closed off. Right? So white is where we write our text, right? You can think of the white section as your Word document, and then your gray section, your R code chunk, as your Excel file, I guess, where we generate plots and calculations and stuff. Okay, so we're going to be importing data, and I posted 2 data sets on Moodle, so I'm going to go and just grab those. Should have done that before, but at least now you know. If I can just click these, click, click. I wonder if it downloaded. No, not that one. Download. Good. For you guys, you can just download the folder, the data folder if you want. I posted that, but that was later, so. For now, okay, we've downloaded from Moodle, that's great. And so what we want to do now, and this is really important, is you have to grab these data sets that we just downloaded. What the? I think the CSV didn't download. No. Okay. Okay, so I figured it out. Because it was downloading as the web page that shows up if I just click here, but that's not what I want. I don't want that. Just want to show you how I got it in case you have the same problem. So you're going to right click and then download linked file. Try it a few times. But if you click this, it'll take you here. And from here, I was able to download linked file. And now it's tipping3.csv. Nice ring to it. Okay. So now tipping3.csv should be in your downloads, as well as the top 100 grossing movies, XLSX file. Okay. These I'm going to move from my downloads. And this is important. Well, I'm going to copy these because I'm going to put them here in my documents. Is a good spot. Stat Labs. That's a good folder to have. And then I'm going to paste these in. Okay. So now this Stat Labs folder is going to be my working directory. Okay? So the way R works is it retrieves data files, and so it needs to know where to go, and that's why it's so important to keep track of your working directory. Okay? So now, because I put my data sets in my Stat Labs folder in my documents, somewhere safe, that's going to be my working directory. Okay, so now back to my R code chunk. You could have just reused, oh, type for bed. Could have just reused the code chunks that are given to you, just empty them out, right? Erase everything in there. Or it's just as easy to make a fresh one. Okay. So we will first import a CSV file. The reason I want to start with the CSV file is because R has built-in functionality of importing CSV files. CSV files, I think usually if you double-click them, they open up in Excel. They behave just like an Excel spreadsheet. It's just only one sheet, right? And so it's kind of a basic Excel sheet. So what we're going to do is we've got our tips data, let's say. So I think this data set was the tipping percentage. So they recorded the tipping percentage after leaving some message on the bill. So it's just going to be a series of tipping percentages that were recorded. Okay. So I'm going to call this tips because calling it tipping 3 is a little bit long. So I just want to use some shorthand methods. So what we usually do is we name our data sets, and then we can refer to the data sets as just those short names. So you want to use short names like tips, for example. Okay. Here's where I get controversial. I use the equal sign just because I think it's cleaner, but if you're looking at any documentation, you'll see kind of an arrow like this. So a less than sign followed by a dash. That's proper. But for most cases, and definitely all our cases, the equal sign will work and it won't fail you. So I have yet to come across a case where the equal sign it doesn't work. So I'm stuck with the equal sign. I like it. It's easier. But I know it's wrong. Okay, so you can use the equal sign or the arrow, it doesn't matter. And spaces here don't matter either. There will be cases where spaces do matter, okay? But out here, we can have as many spaces or non-spaces as we want. So tips, and then, so R imports data using read command. So if we start typing read, it'll come up with different options, right? Some autofill stuff here, so we can just kind of tap through here, and read.csv is the first option. So you can click it or tab into it. So it's saying read.csv, and then it wants to know, what do you want me to read? Okay, so I know I have to read a CSV file. What do you want me to read? And so here we put in quotes, tipping3.csv. It's very important that it's the exact same name as the file in your working directory. So what I sometimes like to do, and definitely for this next one that we're going to do, right, but also this one maybe, is I just copy it and paste it in here just in case, just to make sure. And from here, I'm going to go ahead and run this. So that's the end of our command. So we're saying, okay, make a new data set and read this CSV file, and you'll find it's called tipping3.csv. So we can either copy this, copy, and then paste it down into the console. Remember, the console is where we run our R commands before we knit it, just to make sure everything's working. And here we have a very common problem, right? And so it's good to have seen this error message because it happens a lot, right? And so it's saying error, cannot open the connection, cannot open the file, no such file or directory. No such file or directory just means that it doesn't know your working directory yet, or it thinks you're in a different working directory, right? So that means that you have to set your working directory. And so if we go here, I'll just maximize this, I guess, because this is what you'll be looking at. To hand set your working directory, you can go to Session and then Set Working Directory and choose Directory. And you can hand pick where you want it to go. So this is where I'm going to find my Stat Labs folder in my documents, and I'm going to hit Open. Notice that down here, it shows you what the code would have been for what you clicked your way to. Okay? So it's the set working directory, and then in quotes, my documents, and then Stat Labs folder. So now I know that that's my working directory. Okay, so that's handy. So if you wanted to, and if you want to, you can copy it from here and you can save it up here. I don't need to run it every time, so I'm going to comment it out. But this way I can save it for later and I can just have it there if I need it. So, right, because if I want to use it, I can just uncomment it and run it. But for now, I'll leave it as a comment. The shortcut for running, so instead of copying from here and pasting down here, all you have to do is make sure that your cursor is somewhere on the line that you want to run, right? Or even just highlight, if you have multiple lines that you want to run, just highlight them and hit Command on a Mac, Command Return, or I guess Control Enter on Windows. You'll know if it worked because the line that you wanted to run should show up down here with no complaints. No complaints is a good thing, right? So we just want to see the next prompt. So it's saying, yeah, I did that. What's the next thing you want me to do? So up here in your environment now, when I ran it, you should have gotten the tips data set. So now it's saying, okay, now I know this data set. So in the environment tab, it'll keep track of all the data sets that you've imported. Right? And so we've got the tips data. There's 20 observations of one variable. And if you click the little arrow, it'll give you a preview. Kind of boring for this one, but just good to know. We like to see data in a spreadsheet type of layout, right? So for that, you can just go way over here. There's a kind of a see-through spreadsheet. That's just if you want to have a look at what you imported. Okay, so there's a percentage, and then a list of 20 percentages that they recorded for the tips. So now we've got our tips data set imported. Great. So let's import an XLSX file. So this one I saved for after the CSV file just because R doesn't know. So in our directory, right, we had our top 100 grossing movies. That's an XLSX file. Oof, tough to say. And so while I'm here, I'm just going to copy the name. You can do it later. So we have this top 100 grossing movies data set that we want to import. So I'm going to call it movies equals, and then when I try to type in read, I can scroll through here, and none of these look like XLSX files. You might see some purple options, but we aren't going to use those. So I don't even have them here. Not sure why, but I did just install steps, so that's why. So what do? Well, we Google it. Okay. So we can Google import XLSX. Hey, here it is, into R. Pretty common problem to have. What's nice about R and just programming in general is that it doesn't matter how you get the results, or at least not in my opinion, it doesn't matter how we get this Excel file into R. As long as you get it and it looks the way you're expecting it to, then you did it, right? And so I'll just go to the first option it gives me. Easy guide, so that sounds good. Yeah, whatever. Okay. So we're going to use the read Excel package, for example. So lots of people want to import Excel data sheets for whatever reason, and lots of people are building these packages that we import so that we can use their functionality. Remember, our base R is very kind of bare bones, and so what we do as we need other things, we install packages, and then we call that library. And so to use the read Excel package, you're going to use the read Excel. You're going to copy this. Oops, where am I? So above here, we're going to say install packages read Excel. What's nice is you only have to run the install packages command once. Well, unless you're on a new machine and it doesn't have the package, then it'll have to run it again, right? And for that reason, I'm going to comment it out later. But if I run this, right, so I ran it by hitting Command Enter or Control Enter, and it should just keep working here. And it should end up with something like this. So the downloaded binary packages are here. Great. So now I have this package installed. So now I can comment this out because I don't need it anymore. Right? But it's nice to keep track of what we had to do to get there. So now, every time that you want to use the read Excel package, or at least every time you open RStudio and you have to use it, then we have to use the library command. So we have to enter the library command, library read Excel. And that's just saying, hey, from the packages that you've downloaded, pull this one from the library. So library read Excel that one we do have to run if it's complaining that it doesn't know what the read Excel command is, for example. So library read Excel ran without any complaints, so that's good. So now, if we go back to our little help sheet here, so using the read Excel package, we had the library read Excel, and the only difference between these two commands is that here we have an XLS sheet and here we have an XLSX sheet. So that's the only difference. We have an XLSX sheet, so we're going to copy this. We just pirate code when we can. Okay. I'm going to paste it down here. Notice they use the proper arrow. I wouldn't dare post any code with my equal sign in it. I would probably change it to arrows, but I never post anything anyways. Except this video, I guess. So instead of calling it my data, I'm calling it movies. So I'm going to remove this and I'm going to put it, so I'm going to call movies using the read Excel command, which we can only use because we've installed the read Excel package and we've imported the read Excel library, right? So here and here. So we're going to read Excel and then my file .xlsx. Here again, it's really important that we have the exact same file name as what's in our working directory. So I managed to copy something else over top of it, so I have to go back, copy it, copy the name exactly. And there it is. So now when I run this, there we are. So now no complaints, right? Fresh prompt. Now I have this movies data set. The movies data set has 100 observations of 11 variables. Okay, so if we click down, right, we can see what those variables are and kind of a short summary of what they might be. So the rank, the title, the studio, worldwide, domestic, DOM perk, so domestic percentage presumably, overseas, over perk, overseas percentage, year, genre, and rating. And so R has done its best at figuring out which of these are categorical and which of these are numerical. Right? So you'll see here, it notices, okay, there's some numbers here, so it must be numerical, right? And so sometimes it could be wrong. The rank, numerical again. Or here, the title is a character. And so those must be categorical variables. Right? Why does it care? You know why it cares, because how we treat these variables is going to depend on if we have a categorical or a numerical variable. Right? So it's important. Okay. Trackpad battery's low. Oh, but okay. Yeah, okay. So we've got our movies data set. We've got our tips data set. Great. So I'll just say we first need to install the read Excel package and call the read Excel library. Great. Okay. Okay. So now we've imported the Excel. Okay. Another thing that we will do mostly in the labs is I will just give you a link to a data set and we just download it online. So with a link to a data set, we import through So again, just like we have before, right now we don't have to download it into our working directory. I'm just going to make a fresh code chunk here. But what your lab is going to look like is, don't worry about any of this other stuff, that's old. It's going to have a code chunk like this. So where I give you the code chunk already, and you're going to say, okay, well, this would be there already, but for us, we can copy it and paste it. So I'm going to read it out. So we just call source. Okay, so now source, go to this internet. Of course, you have to have an internet connection for this to work, right? Otherwise, it's going to complain. It can't find it. So if it's complaining that I can't find it, then check your internet and make sure you're on Wi-Fi. So source and then the website. This is just for showing you, right? Of course, I'm not expecting you to type this in. It would be there already, but www.openintro, the textbook that we're using, .org/stat/data/arbuthnot.r, and all in quotes. And so we can run this just as it is, run it. And there it is. Notice that we didn't call it anything. We didn't have to. It is in there, and it's called Arbuthnot, just like it says here. So it already knows that it's a data set, and it's a data set called Arbuthnot. It has 82 observations of 3 variables. And so it has the year, 1629, 1630, 1631, and then the boys, the number of boys I think that were baptized, and the number of girls that were baptized. So that's data that we'll work with later. Okay, great. So we've imported a CSV file, and we've imported an Excel file. It took a little bit more work, right, because we had to install the package, but that's okay. And now we know how to import just data, I don't know, by the internet, I guess, online. We can create our own data sets. Okay. So making a new R code chunk here. I'm going to make a data set, and I'm going to call it my data. So how the simplest way to make a data set and store it in R so that we can use it is to use a lowercase c for concatenate. Concatenate meaning put these things together. Concatenate, so C and then brackets, and then just the list of our data separated by commas. So let's say I have data, and my first observation is 10, comma, my second observation is 9, comma, my third observation is 11, 15, 17, 19, 20. Oh, got kind of derailed. 5. Get crazy. 5, 3, and 9 again. Right, whatever your data set is, you can enter it. For obvious reasons, you don't want to do huge ones like this. You can, but you probably don't want to. Right, so now if I run this, then now I have my data here. Because I only stored it as one string, right? So it just knows my data. It comes in and it looks a little bit different than the data and the values, but it'll behave similarly. Okay? So this is the simplest way to make your own data set. So probably all we'll need for this course. Okay, so now we've got all these data sets that we can work with. So make a new header and exploratory analyses in R. I'll give us some room here. So exploratory analyses is just where we poke around and we look at our data and maybe make adjustments if we have to, right? We can have a look at maybe this Arbuthnot data set in the spreadsheet, right? And it'll show us, okay, looks good. So we can just scroll through here and we can't and we wouldn't make any changes in here. All our changes are going to happen in our code. Okay? And so it might be tempting to adjust your data set so it's nice and clean before you bring it into R, just because it would be way easier, and all guilty, right? But we should be doing all our adjustments in R, because that way it's reproducible, and that's really important, right? If we go back and we have to fix something, then if it's reproducible, then you can just look through your code and take someone step by step through what you did to change the data from the original state to the final state. And then you could apply that same code to a similar data set and it would just be done already, right? So that would be nice, right? Okay. So let's get started with some basic exploratory commands. So I'm going to make another R code chunk here. I have to close it up. 3 ticks. So now that I've pulled in these data sets, I'm not going to work with my data so much. I'm only going to work with these Arbuthnot movies and tips data. We've seen the summary command. So if I want a summary of Arbuthnot, for example, right, then I can just write summary Arbuthnot. It'll give me a summary. Oh, I don't like, this is a default setting, but I don't actually like it when it shows me this. So I'm just going to close it. I like it showing down here, but that's personal preference. So down here we have our summary of our Arbuthnot data. So it has the year, look familiar, the minimum, the first quartile, the median. It throws in the mean in there too. Why? Because then we can compare. If the mean and the median are similar, that means that we have a roughly normal distribution, right? And then we have the third quartile and the maximum, right? So it'll generate these things for all our points, right? So for example, if we look at the summary of our movies data, the summary of the movies, close this. I'll have to change that setting somewhere. The summary of the movies data set, the rank is a number, right? So it'll do it for that. But then the title is just a character, so it's saying, I'm not going to do a number summary on this, right? But we want to be careful because sometimes we store data as numbers, but those numbers represent categories. So we have to be careful. Okay. We can ask things like the dim command. The dim command just asks for the dimension. So if we ask for the dim of Arbuthnot, it's saying there's 82 observations and 3 variables. We actually have that information here, right? So this is basically the dim command, right? The dimension of each data set. So it's not that fancy. If you want to get a quick peek at your data without looking at all of it, so looking at all of Arbuthnot, for example, you can just type in Arbuthnot and run it, and then it'll show all of the data. Oh, it didn't do it here. only showed it up here. Oh, that's annoying. I'll run it again. Actually, I'll show you this. Down here, if I use my up arrow, I can flip up through commands, down and through commands that I've run already. It's handy. Okay, so here, I can see my Arbuthnot data and I can get a general lay of the land to see what it looks like. Sometimes we have huge data sets, so then instead of just saying the actual, just the name, we can say, I want to see just the head of it. So head of Arbuthnot. Head of Arbuthnot. It just shows the first 6 entries. Same, you could look at the tail of Arbuthnot if you want. Tail of Arbuthnot shows the last 6 rows. I'll just use this until I've got it changed. What else might we want to do? Let's see here. Okay, so we've kind of poked around this data set, and we can do some other things, like we could look at the length command, length of Arbuthnot. Three variables. It's not that great. Great of a find. What else can we do? We can do, well, what if we want to just look at one of these variables, right? So let's call, so we want to look at the names of Arbuthnot, asking it, hey, what are the names that I can use, right? The names of the columns in this data set. We have year, boys, and girls. All right, so then if I just do Arbuthnot, and I'm just tabbing, when it knows what I want, I just tab into it. Arbuthnot $, and the $sign is what tells it to go, okay, so go into the Arbuthnot data set, and then $, just go into this one column. So I want to look at the boys, for example. So now it's just going to give me a list of the boys data, right? So if you compare it here, the boys column started with 5218, 4858. Yeah, so it's going to be the same all the way through. So if I wanted to just use this column, right, I might name it boys. Boys equals Arbuthnot $boys, because it's going to be a little bit tricky, right, to write this out every time. It's proper and you still can, but it's just going to be easier to talk about just the boys data set. And then we can talk about the girls as well. The girls are going to be the Arbuthnot data $girls. So now we have these columns, right? We've ran boys and girls, and we've just separated them so that now I can look at, well, the same thing, the summary of the girls. So now it's just giving me a summary of the girls data set. What's nice is that now I can look at things like the max of the girls. Anything that you might want to do, you can do, right? It's just a matter of Googling your way to it, or you just have to have the mindset of, okay, it's possible, how do I get there? And so You want to find the maximum, for example. Well, try max and see if it works. You want to find the minimum? You bet. The minimum data point of girls, 27, 22. The maximum, 77, 79. Great. We can do things like the mean of girls. Now I should have checked this because I am pretty sure that the Arbuthnot data tells us how many boys and girls were baptized each year. And so it's basically a birth counts data. Okay, so the mean number of girls that were baptized in this data set is 5,534.646. So we've done all this work and we haven't really been knitting this, but we should be knitting it because I'm still untitled. I haven't saved anything. That's bad news bears. So I'm gonna knit it just to make sure that everything's hunky-dory. Save as lab 2. And where in my stat labs? Because it knows because I set my working directory, right? So that's nice. In general, if you haven't set your working directory through the session, right, then you'd want to make sure that you change the working directory here. So save it in the same working directory as your data sets that you saved, right? Otherwise, it won't know where to go. So we'll save it. That should show that it's working here. And we end up with something like this. Here's kind of a play-by-play of everything that we did. So everything looks good. Great. Nice. Okay, so it looks good. I can close this. And so we looked at zeroing in on a particular column in a data set. That's good, by using the $sign command. Okay. What if I want to just use, I want to just look at, now let me see here, the Arbuthnot data. I'm going to use square brackets right up on the Arbuthnot data because the square brackets are saying, okay, inside Arbuthnot, you have rows and you have columns, right? And so the square brackets, I want to say, okay, separated by commas. I'll just type it out here and replace it because it needs numbers. But here you would have your row, and here you would write your column number. Okay. So if I want to see in the second row of the third column, I just want to see, I want to zero in on that particular data point. I can run that. And in the second row and the third column, my data point is 4,457. So if I look here, it might be easier if I just look at the spreadsheet. This is just to confirm that it works. Right, in the second row of the third column, right, 4,457. Great, that's what it told me. So if you want to see an entire row, Arbuthnot, and then square brackets, you can just leave the row empty and say, I just want to look at the third column. So now it's going to give me all of the girls' data, right? Because that's the third column. Same idea, Arbuthnot. If I only want to look at the second row, but all the columns, then I just leave the column empty. Second row, the year was 1630. The number of boys baptized were 4858. Number of girls baptized were 4457. Nice. So sometimes we need to be able to get to one particular data point, right? And this is how we're going to do it. Great. Okay. So we've done a lot, right? We've imported data And then we've poked around in it. We've singled out single columns or variables, right? And we've looked at the summaries and little things we might want to do, the minimum, the maximum, the mean, little calculations like that. And then we've zeroed in on a particular data point that we might be interested in. And so we've got quite the toolkit already. So that's it for lab 2. See you in lab 3, I guess. Oh, hey guys. And yeah, see you in lab 3.